Hello, welcome to this presentation. My name is Rafael, and I'm going to try to give you an overview of how we are using Zabbix at the University of Oslo, why we started using the Zabbix at the university, and some of the problems we have had during this time and the status right now. Before we start talking about Zabbix, I have to give you some information about the University of Oslo so you get an idea of what we are dealing with. The University of Oslo is the main educational institution in Norway. It has around 30,000 students. We have around 6,000 employees. The amount of servers we are administrating are around 3,000, both Linux and Windows. We have 6,000 clients of all kinds, both Windows, Mac, and Linux. The amount of storage we are administrating is around 13 petabytes of data. We have more than 2,000 routers, switches, and Wi-Fi access points. Around 1,600 databases of all kinds. More than 1,000 printers, and the amount of data that goes in and out of our network in a normal day is around 26 terabytes of data. So you can get an idea of what we are dealing with in terms of infrastructure. In the last 2 years, we have been working with four areas, and we have tried to improve and upgrade them. We have been working with how we get information of things running in our infrastructure. We have been working with monitoring, with trending, and with log analysis. We started working with monitoring in 2014, and it was clear to us that we have to do something with the situation we had. We have a really old Negios installation. We were having really issues with the performance. It didn't scale anymore. And we have also difficulties in maintaining all the configuration files that we need to have the system running. And especially because we have a lot of people that are involved in the administration of the infrastructure. Our dream looked like this when we started. The reality was something more like this. We had many different systems doing monitoring, especially doing just monitoring of a little part of the infrastructure, some types of components. And the worst of all is that we didn't have any kind of integration between these systems, so they were not talking with each other. One of the main reasons why the situation was like this is because we have a lot of people involved in system administration. We are around 300 persons working with IT-related jobs, from administration to development and support. And on top of this, we have some dedicated monitoring management systems that we had to use because it's the type of tools that we get for some kind of solutions like Oracle Cloud Control or vCenter, vCops for VMware administration, and so on. One of the biggest problems we had when we started talking about we are going to change how we are doing monitoring was that the people was very, they don't like when you come and you say, well, now you are going to do things in another way of what you have been doing for a long time. And this comes on top of the time pressure they have with all the things they have to do all the time. So it was really obvious for us too that we have to have a high grade of automation, so we could get as much as possible into the system without people having to do a lot of configuration things. The list of functionality and requirements that we wanted to have, it was very long. The most important ones for us were we wanted a system that could do some distributed monitoring for two things. We wanted to have the opportunity of scaling the system if it was necessary, but we wanted also have the opportunity of accessing some restricted areas in our network. Another thing that was really important for us was to have a system with an advanced access control system with roles and user groups, so we could control how these 300 people were going to access the system, what they were going to be able to do there and see, and so on. Of course, dependencies was something really important for us, both for avoiding unnecessary alarms, but also try to get root cause when something happened. And the last one that was also very important for us, we wanted a system that was able, where we will be able to integrate that system with other systems, both to get data in and out of it. And it was obvious for us too that we wanted to do this through some type of API and not editing some configuration files all over the place. We started reading about all the monitoring systems out there and trying to find out what they could give us. And finally, we chose two, Zabbix and Ishinga, and we started to testing these two really in deep. They could deliver most of the functionality we wanted, but there were two things that, they were the two main reasons why we chose Zabbix. It was the API, so we could talk with the system, and it was the access control system that we need for our users. So they were the two things that really made the difference. We have, of course, some skeptical people that were not satisfied with us saying that we were going to use Zabbix. One of the main things they were saying is that the user interface was very old and was 90s and it was difficult to use and so on. And some others were complaining that what are we going to do with all these Nagios plugins that we have and you have out there? How are we going to do it? But we were so impressed with the core functionality that we were sure that these things will get better after a while. I'm going to give you some information how or some decisions we had when we decided to take Zabbix as our new monitoring system. The first thing was that we wanted to use our standard infrastructure to run this new system. We decided to run everything in virtual machines. We were not completely sure if this was a good decision, thinking of performance-wise, how the system will react, but we did it. We are running everything in Red Hat Linux version 7, using PostgreSQL as our database backend, and we are using CFanian as the configuration manager to orchestrate the whole configuration of the system. Another thing we did was to have dedicated servers for all the Zabbix components in the system. We have a couple of web servers on the top for the dashboard and the API. We have dedicated database server, dedicated Zabbix server, and we have multiple proxies all over the infrastructure to get all the data that we are getting in the system. As you can see, we don't have any replication of the database. We don't have any redundancy, for example, in the Zabbix server. Some are core components of the system. But that's because we are using the functionality that VMware is giving us in case a physical host goes down, or in case the physical host running one of the virtual servers have problems with resources. Another thing, you probably know that you can use all the components in Zabbix can be used in two modes, active and passive. What we did, and it was clear to us too, that we wanted to use the active modes all over the infrastructure, both for security, because we didn't want to have another port open in the network, but also for performance, because in this way we didn't have to use resources to ask all the agents if they have something we wanted, and so on and so on. So now we just wait for the data to come in, and it's working very well. Another decision that it's really important, we think it's really important, is to decide the update interval of the things you are getting in the system. You really have to think how often you want to get the values in to have a good monitoring experience. We are doing that. We have everything from 30 seconds to 1 hour, but I can give you an example of what happened when we started using Zabbix in the beginning, and we activated the monitoring of all our disks. We were getting all the data in every minute, and after a few minutes we activated this, we were up in 3,000–4,000 values per second. We saw that this won't scale if we get all the data all the time. So we were we went through all these updates interval and see how often we needed to get the things. We took, for example, the monitoring of the disk, we took it up to every 10 minutes. It's okay for us to get how they are working every 10 minutes, and we reduce, for example, the amount of values per second by 10. So with this infrastructure, are we getting around 3,000 servers are registered in Zabbix. We have around 320,000 items in the system, around 200,000 alarms or triggers, and we have around 400 users with access to the system, but only around 30–40 are in the system all the time. So not all of them are using the system at the same time. I'm going to give you some information about how we have automated a lot of things around Zabbix to do our job easier. We have one term that is very important for us, that we have defined some site admin. A site admin for us is somebody that owns a server or an application or something that we are monitoring. So, and we use this site admin term all over the place. You are going to see how we do it. So site admin is the owner of something that we are monitoring. We are using all the host groups functionality in Zabbix. We have a host group for roles, for all kind of roles. If the server is a database server or a web server or a Linux server or whatever. And we have host groups for all the site admin groups we have in our system, and we have groups for templates group, host groups for all these site admins too. Maybe some of this functionality we have implemented with all these host groups will go away with the new functionality in 3.2 with tags. I don't know. I have to see how it works, but maybe tags will take over some of these. What we have is that we have several site admin user groups, depending of where the people work and what they own in the system. And by default, all of them have read access to everything, but only read and write access to the site admins groups they own. In this way, they can have their own templates, and they can configure all the machines or applications that they own without having access to the rest of of the infrastructure. We have a product or a software that we have developed at the university that we call NuHem. It's a solution that we are using to get configuration and system information from all the hosts at the university. What we do is we have an agent running in all these machines that will get this configuration and system information. They will send it to a central NuHem server that will index all this information, and we can access this information through an API. It's a really great software that we are using a lot when we have to automate things. I'm going to show you very briefly an overview of the automation process for servers that we have. We start with, we can have Linux or we can have Windows host. Somebody install them or create it. When they are in place, we have our configuration manager goes in and start configuring these machines. The most important thing that from the monitoring perspective is that they install the Zabbix agent and they configure the Zabbix agent, and the same with the NuHem agent. They use some information we have in a database to save information about what kind of role that server has, who owns the server, and so on and so on. When these informations are in the servers, the NuHem agent will send it to the central server. It will get indexed and it will be ready for us to use. At the same time, we have information about all these Zabbix user or site admin user groups that we have been talking about in our LDAP infrastructure. And then we have some kind of automation that will use all these roles and site admin information to create all the host groups that we need to create new machines, to delete old ones, and of course to link all the templates necessary for a server to work based on the role of the server. So in this way, we get everything in a very easy way. On top of this, we have some devices and services where we cannot install this NuHem agent, and then we have some kind of bulk updates to update the system with these devices and things that we have to monitor. We have had some problems too during this time. The first type of problems that we had were in the beginning was some type of problems that were difficult to explain. We really didn't know what was happening, especially with the Zabbix agent and external checks. What we found out after a while is that we were using Linux was active in all our servers, and that was stopping the Zabbix components working properly. So be careful if you have some security measures in your systems, and because they can do some nasty things, and things won't work how they are supposed to be. We have also some problems with performance, and especially the database performance. We have a period where we have really huge performance issues that were really stopping us from delivering a good monitoring system. If you see here the graph in the top, that's the CPU use of the database server. The most important part is the yellow line. That was we have a really high system CPU use in this period, and we didn't really know what was happening. The amount of data coming in the system was the same as before the problem. We tried to tweak and to do some changes in how VMware was using the memory and the CPUs for this virtual machine, but we really didn't get anywhere. You can see here is the load. We have some really nasty peaks with 50, 100 in load. Every time we were in that period, Zabbix was not able to process all the data coming in. The queues were going up very fast, and yeah, it was messy. What we did was to run some profiling to find out the system calls that were going in the system, and we found out that something that was, if you see up there, a system call called compaction alloc. We didn't know what that was, so we have to find out what it was. And it looks that it's a process that the kernel start to make some defragmentation of the memory when the kernel thinks it has to be done. We really didn't know if it was the reason why we were having these problems, but we tried to do that and something with how we were using the memory. We have some experience with Oracle servers using huge page configuration that were giving a very good performance gain, and we did the same with Postgres. And we were lucky because suddenly the problems we were having with this system CPU use were almost gone. We still have some problems there, not problems. We have still some use of system CPU that we could not explain, but Zabbix was working good, and we were processing things okay, so we were very happy. Some weeks after this, we have to move the VMware to another, or the virtual machine to another VMware cluster with more power and more resources, and suddenly the CPU use got even better, and then we could start explaining what this was. They were like when we were running the backups in the database, or the Zabbix housekeeping was doing their job, so things were really good. So again, same system with the same amount of data coming in, the same amount of things you are monitoring, and three very different situations. Again, it was not a problem of Zabbix. And if you are running things in virtual environments, you have to be careful with not over allocating resources, and you have to have the resources. The last type of problems that we have in this period was related to automation. There is something that it says that with great power comes great responsibility, and automation is great to fix things very fast, but it's also great to destroy things very fast. Because of this, we tested our automation software or scripts, the things we did very much, and we thought we had the things under control. But of course, we have a bug that was triggered in a very special situation that we didn't thought was possible, and one day the whole thing exploded. 2 minutes after the automation process was finished, we got the first telephone call about people complaining about where are my alarms, where are my hosts, what is everything? Zabbix was completely empty. We got pretty shaken, but this is not a nice situation. But we find out that corner case that was the reason why the automation did what it did. We fixed it, and the good thing with automation is that everything was back again fast when the reason was gone. So, yeah, in the same day we lost everything and we got everything back without having to do much work. Another thing we have been doing for our users is we have been trying to integrate Zabbix with other systems to make it easier for our users to access data from Zabbix. What we have done is we are using a great Grafana plugin that you can use to access Zabbix data from Grafana. Here you have an example of a Postgres database, and all the information in Zabbix is shown in a really nice way in Grafana. Another example of our dashboard with Zabbix information about our Elasticsearch cluster. This one is using the last version of the plugin and the last version of Grafana, and it has really nice functionality with tables. You can show some trigger information from Zabbix directly in Grafana, and it works really good. And the best thing is that people can use this information from Zabbix and do their own dashboards with information from other systems. So really great integration job there. We are sending also all our alarm information to ELK. We are sending it to Logstash and Elasticsearch. It gets indexed there, and we use that information to create some dashboards in Kibana, so people can access alarm information in another way and do some analysis if they want about the history and things that have happened in the system and so on. And again, not only they have the opportunity to do their own dashboards with Zabbix information, but they can correlate this information with other information we have in Elasticsearch. So, as you can see, Zabbix is a central component in our package of tools we have to try to get some control over our infrastructure. Really nice and easy to integrate with other systems. After the presentation yesterday about Rundeck integration, that's something that we are going to try right away when we go back. It was a really good idea. So we are just trying to find other ways of integrating Zabbix with the environment around it. We are not finished, and probably we will never be finished, so we have still things to do. We want to continue working with doing procedures and policies of how to react and what to do when something happens and an alarm is generated. We still have work to do that, so we have all these groups working more together. And we have, of course, to continue working with dependencies to make the system and avoid alarms that don't have to be there, and to try to get some root cause when something happens. That's difficult, even if we have some functionality in Zabbix. It's difficult to get the data needed to configure Zabbix in an automatic way, because we have such a big system that we cannot go in manual and start doing these relationships. We need some data to do it. So we'll see what we get that in the future. And of course, we continue working with avoiding false alarms, and we have great functionality in Zabbix for configuring these triggers and to control when they happen. And that was actually everything I have to say.